Now that we've looked at the basic trig identities, we moved into some more complex identities that will come in handy as we solve trig equations. First, we're going to deal with identities that address the sum and difference of angles. I've listed here the identities that we're going to be dealing with. Notice we have, when we're adding two angles together, remember u and v are going to represent angles. It's the sine of u times the cosine of v plus the cosine of u times the sine of v. You'll notice here when we do the difference, the only thing that changes is the sign. With our cosine identities, notice the pattern's a little different. And our tangent identities are listed here for the sum of the tangents and the difference of the tangents. So where do these come from? Well, let's consider the unit circle here. If we look at the unit circle, we can see that we're looking at the angle u, and then we're looking at the angle v, and then the angle u, and then this distance becomes u plus v, which, remember, we're dealing with that idea of our sum of angles here. Now, notice that since we have angles that are the same, this distance PQ is going to equal RS, because this angle has a magnitude that's equal to this angle. Using our distance formula, then, what we can do is we can make a comparison here. If we, from our unit circle, remember how to find our points. Remember, our x value is going to be cosine, so in this case, cosine of v. Our y value is going to be sine of v. Here, because it's the unit circle, we're going to have the point 1, 0. And then for q, our value is going to be the cosine of u plus v. Remember, we're adding those two angles. And then our y value is going to be the sine of u plus v. And then for s, this is going to be the cosine of u, because remember that the cosine of negative u is equal to the cosine of u when we talked about even and odd functions. And our y value is going to be the negative sine of u, because hopefully you remember that the negative sine of u is equal to the sine of negative u. Now, using our distance formula, and if you don't remember the distance formula, you can go back and check that out. We can calculate that the cosine of u plus v minus 1 squared plus the sine of u plus v minus 0 squared, all of that's under the square root, is going to equal the square root of the cosine of v minus the cosine of u squared plus the sine of v plus the sine of u squared. Because remember, notice here, the cosine of u plus v is the x value here minus the x value here. So that's calculating our distance between p and q. And then here we've got the y value and the y value. For the right side of the equation, we're using our x values between r and s, and our y values between r and s. So now, as we perform our calculations on this, if we square both sides, that's immediately going to get rid of the square roots that are there. And then if we FOIL everything out, we end up with the cosine squared of u plus v minus 2 cosine of u plus v plus 1. That's coming from right here. Plus, we just end up with sine squared of u plus v, because that 0 doesn't play a role. And that's going to equal, again, when we FOIL the right side, we end up with cosine squared of v minus 2 cosine of v cosine of u plus cosine squared of v. And then I'm going to do the next part below here for this part. Plus, we have the sine squared of v plus 2 sine of v sine of u plus sine squared of u. Remember from your identities that we know that sine squared plus cosine squared equals 1. So I can combine this, and I get 1 minus 2 cosine of u plus v plus 1 equals, and then over here, I have this comes out to 1, and this comes out to 1, minus 2 cosine of v cosine of u plus 2 sine of v sine of u. Now when we simplify, I end up with 2 minus 2 cosine of u plus v equals 2 minus 2 cosine of v cosine of u plus 2 sine of v sine of u. Using algebra, these cancel, and then if I divide everything out by -2, I get cosine of u plus v equals cosine of v cosine of u minus sine of v sine of u. And remember there, we divided by -2 is why the sign changed. So that proves one of our identities. The other identities can be proved in a very similar manner, but I will leave those for you to try as you wish.